Thanks, guys. So today I want to talk to you about a moonshot. That picture that you see above me was photographed April 10th by a lander, Bereshit, that SpaceIL manufactured. And I want to tell you a bit the story about SpaceIL and about the moon landing. So like every good story, it started in a bar. It was me with two friends, and we had a little bit too much to drink, and we were like, why won't we just go to the moon and try landing there as part of a competition that was made by Google called Google Lunar X Prize, and we're like, yeah, we should do this, and it never faded away, I guess. We started as three friends in a bar, but SpaceIL has become a much bigger organization than that. You can see actually these are all the engineers, the team, that actually made this mission possible. These are the guys that actually built the spacecraft and made it a reality. And I want to point out three fellows out of this picture, Morris Khan, Idon Tebi, and Ofer Doron, which actually led this effort and made this a mission into reality. This is our spacecraft a couple of months before it was launched. The spacecraft is about the size of a coffee table, weighs about as a Mini Cooper, and you can see that most of it is actually fuel tanks. So the majority of the spacecraft is composed of fuel tanks to take us the enormous distance, almost 400,000 kilometers to the surface of the moon, and that thing was launched. But before we get to the launch site, we had to pick it up and ship it to Florida. We got a first-class ticket for the spacecraft to get into this Boeing. But since we're a private organization, we're not a government, we're all about saving costs, because getting to the moon cheaply is the trick. Not getting to the moon, that was done 50 years ago, as you guys heard. But getting to the moon cheaply is a big problem, so we had to save costs. How do you save costs? Well, you don't get a full plane for yourself, so we shared the ride with some oranges that we dropped off along the way, and this got us all the way to Florida. We got a little discount there. And we were assembled on this Falcon 9 rocket. This is in the morning of the launch. By the way, standing next to this is an enormous beast that actually lights up and flies to space. And you can see that the rocket, the Bereshit, is actually on the top there. And if I want to zoom in, you can see that the first stage of the rocket is kind of dirty, which is kind of interesting because this is a reusable rocket. SpaceX actually launched the same rocket multiple times to be able to save the cost of bringing it back down and then doing it again instead of disposing them. And the rocket has been used before. This is why it's dirty. And I was walking around with the SpaceX representative, and I asked, we paid so much money for you guys, can you just repaint it? Well, they wanted the raw coloring to this. Inside the fairing of the spacecraft, of the rocket, we are just, I'll just do an X-ray view here and put in another picture so that you can see Bereshit is not traveling alone. So we have a communication satellite here painted in green that we share the ride with. So we basically got a shotgun view of the ride to space, and we share the ride with another satellite. This, again, allows us to save cost, because we don't need a special ticket. We're doing just the Uber pool of space ride. We can basically split the cost between the two of us. And that's turned out to be very useful in reducing costs and making this into something that is a possibility for a private organization. This is the launch itself. It was very impressive. The sky lights up, and you can see people that are actually viewing. This is not a flashlight. What you see behind me is actually the light from the rocket shining on the people under. And you can actually see that and see the excitement. And this is the view that we saw as the rocket was going to space. In a kind of very symbolic way, as the rocket was going over the horizon, the moon just came up. So we got a first view of this is the target, we want to get there. But the journey did not start off I would say, with the right foot. Some kids or spaceships are born troublemakers, and this baby did. The first thing that we noticed was that a special sensor that's called a star tracker, I pointed it out there in the arrow, did not work well. What does it mean? Well, a star tracker is a type of a camera that takes pictures of the night sky, or just the sky around the spacecraft, and compares it to a map. So we're able to know where the camera is pointing, and as a result, where the engine is pointed, because this is really important. You want to fire the engines in the right direction. So when the spacecraft tilts, you can see that the star's map shifts around, and the star tracker takes pictures of that and is able to tell us where we're pointing at. Well, the star tracker was blinded by the sun Oops. Yeah, there you go. The star tracker was blinded by the sun at angles that we did not expect. Now, this is a problem because if the camera cannot see stars, we cannot determine where we are and where we're facing. But we couldn't also test it here on Earth, because on Earth, you can see stars only at nighttime. But then you don't have the sun to blind you. In the morning, you can see the sun, but because we have blue skies around us, we cannot see the stars. So how do you test if the sun is going to blind you at certain angles when you cannot do both? A lot of the things that you do when you're traveling into space, you cannot really test end-to-end here on Earth. The environment is different. And for that reason, some things are different than you expect. But the team in Israel is actually a pretty smart team, and they were able to figure it out quite quickly, and we learned to live the problem. By looking away at specific angles, we were still able to run the mission properly, even though we were not aware of this problem and only discovered it once we were launched. We did multiple orbits on our way to the moon. So Apollo, they took only 4 days because they could do a direct trajectory towards, imagine this is the moon. This is a moon rock that we carry on. So they did a direct trajectory towards the moon. It takes only 4 days, but they had the money to pay for a full rocket. We, as I mentioned, did Uber Pool. So Uber Pool usually takes longer. So we had to do multiple loops around the Earth before we could capture with the moon. By the way, this is the end of the presentation. Does anyone want this? Yeah, there you go. OK. Oops, sorry. Usually it works better. I guess in Canada it's different. So the distance to the moon is about 400,000 kilometers, and our journey took about 6.5 million. So it took us about almost 2 months to get to the surface of the moon, or to get to orbit the moon. We took selfies. This is the first selfie that we took, which you can clearly see the Earth is flat, and a little point there, yeah. So we took a selfie of the Earth, and we took a bunch of selfies. Unlike that selfie that happened in space, this selfie happened 2 years ago in IdeaCity. And unlike this one, we actually took it to the surface of the moon. So interestingly, we were able to make this time capsule and install it on the spacecraft. And I actually have a piece of it with me here. This is a piece of the time capsule that actually went to the moon. Not this one did not get to the moon, but a copy of this one is actually on the lunar surface right now. And we took with us 30 million pages of books, of pictures of Wikipedia, also pictures of people around the world, and also the IdeaCity, the IdeaCity, I think it was, picture with us to the surface of the moon. Thank you, thank you. We're going to try to take another picture with you guys for the next mission, so hold on that thought, we'll do it in the end. We did some orbiting around the Earth, and then came the time to say goodbye. Because about 1 month, 3 weeks into the mission, it was time to leave Earth orbit and to capture with the moon. One last round we're doing around the Earth, we gave a shout out to all the people in Israel to wave their hands about 4 in the afternoon to the spacecraft. And we tried to take a picture of that, but as God willing, Israel was covered with clouds, so we couldn't see anyone. But believe us, we tried. It was a little too risky, but it's okay. And then came the most intense moment of the mission, and that is the Lunar Capture. The problem with Lunar Capture is you cannot try it twice. If the engines don't work, if something goes wrong, you're for sure to miss the moon, and you're going to venture to infinity and beyond. And we had one shot to do that, and it worked perfectly. We captured with the moon, and we became the first private interplanetary mission to do that. Thank you. The picture that you see behind me is a picture that you cannot see here from Earth, ever. This is what's called the far side of the moon. Pink Floyd called it the dark side of the moon. That's a mistake. You can see it's lit. It's not dark. But it's the far side of the moon. This is the side that never turns to Earth. And as we were capturing, we were actually turning back and taking those kind of pictures. We captured in a new moon, which means that the moon looks completely dark to us here on Earth, but the other side is completely lit. And this is why we were able to take such a beautiful picture of the far side of the moon. Well, we had a lot of fun orbiting the moon, waiting until the landing sites. The sun rises over the landing site because part of our systems are solar powered. So we want to make sure that we have sun on the landing site so we can actually manufacture, and we can actually land and see what we're doing while we're landing. And so we waited until the landing site became lit, which actually happened on April 11th, 2019. That was the time that we actually began the landing process. Now, the landing is the most difficult and dangerous part of the mission. As I mentioned, there's nothing like landing on the moon here on Earth. The environment is different, so we cannot try it start to finish on the surface of the moon. We can try parts of it, but we cannot try all of it. And if this is not challenging enough, the moon is 400,000 kilometers away, which means it takes light more than a couple of seconds back and forth to get here. So radio signals traveling at the speed of light actually take a couple of seconds back and forth. So we don't have a joystick here on Earth just saying, oops, we see some problems, go left, go right, because by the time the signals go back and forth, we're going to be in a completely different location. So the spaceship has to do this on its own. And this is why it's so difficult. We are traveling at about 1.6 kilometers per second. This is the orbital velocity of the moon. And we needed to get it to 0. And we have 15 minutes to do that. 1.6 kilometers per second is faster than the speed of sound. And we need to get to 0 within 15 minutes. That's a hell of a break. The moon doesn't have atmosphere, so we cannot use parachutes. Our only option is to use rocket engines. And we have to fire them exactly as planned and fire them hard. If for some reason we don't fire them in the right direction or they stop working, we're for sure to crash on the surface of the moon. There's no doubt about it. And this is why the stakes were high on that day. You can see the ground station. You can see all those people, all the engineers at SpaceIL and Israeli aerospace industries sitting on their command modules, trying to see what's going on with the spacecraft and if something goes wrong to take action on this. Plus, we had a bunch of Israelis at home looking at this from their TV, from parties around Israel. Everybody was looking about this first Israeli attempt to land on the surface of the moon. The first part of the mission went perfectly. We got some data from the spacecraft. You can see it on the screen on your right. These orange circles means that the engines is firing properly. We're slowing down. We're getting the data. We're getting the telemetry. And everything goes perfect. We got another selfie, of course, because you have to, this time with the surface of the moon. And you can see, by the way, we're getting closer and closer. You can actually see mountain ranges on your right. You can see the mountain ranges. We look at the moon, it looks round. Here we see mountain ranges. The moon is coming in fast. We got a break. And then we got the notification, IMU number 2, not okay. What does that mean? IMU is one of the critical sensors for the landing. It's something similar to your phone, but on the spacecraft, it tells you how fast you're accelerating and how you're braking. And this is why we use it for. This is why it's so important. We had 2 of those because it's that important. But IMU number 2, not okay. You see, we're less than 5 minutes before touchdown. And then the guys at the control room had to make a decision. We could leave it as it is. We have IMU number 1, and we can finish the mission with IMU number 1. Or we can attempt restarting IMU number 2, and then we have both of them. If we don't restart it, and something goes to IMU number 1, then we're for sure to crash. The decision was made in less time than I've been talking about this slide. Remember, we have less than 5 minutes to touchdown. So the guys made their decision and attempted restarting IMU number 2. In a chain of events that I'm not going to talk into right now, we lost communication. And engine shut down. Remember, what does it mean? At that point, we were traveling really fast, and attempts to restart the engine were going to some extent well, but at the end, we got to the surface of the moon at about 900 meters per second. That's very fast. Well, what's now? First of all, NASA took actually a really cool picture just before, a couple of months before the landing. You can see we are coming from the north there. And then this is the before picture, and an after, and a before, and an after. You know, every startup wants to make an impact. We guys, we did it. We did it. We wanted to land on the moon. Well, we did it in too many pieces. Okay, so what? I have a friend that says, a pilot that says, if the plane is on the ground, it's called a landing. I have many of those, by the way. We crack jokes all night about that. All right, let's talk a little bit about the impact here on Earth. So a big part of the mission was to use this to inspire kids. You know, kids today, they're not as interested about sciences and engineering, a lot of them. They're much more interested about being celebrities and playing video games, which is important. You know, I like video games, but also doing science and engineering. And you can see how excited kids get, where we talk about the possibility that they would one day build their own rocket ships and go to the moon with them. You know, and there are two types of kids. When we do this exercise, we tell them to put some stickers with what they would take with them to the moon before they fold this model spacecraft. And there are two types of kids. The first one is, you know, they want to take a teddy bear and their favorite book. And there's a second type, which is much more pragmatic. They want to take an oxygen mask and a rocket back. And it's really interesting to see what they're thinking about. And we actually, at SpaceIL, we had an enormous volunteering team that I want to do a shout out. These amazing people actually walked school to school and talked to all the kids they could put their hands on and actually made this happen. And we reached over 1 million kids in the program talking about space exploration. Hopefully, some of them will choose that as careers and cure cancer and global warming and everything amazing that you guys have been hearing here in the conference. We also were the first private lunar mission, and so now, and we did it in a fraction of the cost. So now we can say, until that point, only government got to the surface of the moon. This was a government thing. Now, private organizations can get to the moon. This is a new era. And you can see there are many more, and ever since we got to the surface of the moon, there are many more companies. Jeff Bezos announced, and NASA selected 3 companies now to make a private mission that would go to the moon. So hopefully, in the near future, we would see a lot more landings, a lot more science going on the surface of the moon, and maybe one day we can all go, if we want to. My fiance doesn't allow me to go, though. That's... All right, so what did we learn? We learned that things don't work first time around. But also that science and engineering is hard. But my favorite lessons comes from the name of the spaceship, Bereshit, which we actually did not make, I did not came up with this. We actually sent it out to the public to say, what name would you think that the spacecraft should have? And the public voted for Bereshit, which is actually a very interesting word. In Hebrew, it's the name of the book Genesis, but it also means in the beginning. And Bereshit is actually the first word in the Bible, and it starts with the letter Bet, which you can see here. In Hebrew, we write in the wrong direction, so actually you read it that way. So Bereshit starts with the word Bet. And a Bet is a really interesting letter, because if you look at it, you cannot go up, you cannot go back, you cannot go down. You can only go forward. Thank you. Should we take another picture, another selfie? Yeah, okay, Gene.
So I was watching the transmission live, and we got to the ending that everybody now knows. And Netanyahu turned to that Mr. Khan, and right then and there said, "Are you in for the next one?" Because he put up, what was it, $65 million?
$45 million.
$45 million.
Yeah, so Morris Khan announced that we're going to try and see if we can do a second landing. It's still not certain, but we certainly want to go and do it again, because things don't work the first time around.
It's splendid. Let's do our picture.
Let's do our picture. Can you take our picture? Actually, maybe your camera is better than mine.
Yeah.
Okay. If you have a wide screen, a wide one, that we can see everyone.
Oh, yeah.
Well, first we're going to take our picture.
Oh, okay.
Yeah.
Sorry.
Let's do it right.
Okay.
Oh, that's beautiful. Here we go. This is the real one.
Thank you.
Thank you.
Thanks, Yonatan.
All right, should we do one with the audience?
Yep.
Okay.
You're going to do that?
I'm going to do that, but you also
Am I
need to
gonna
do it because
stand
my
next
phone is
to
not
you?
very great. So just guys, just one thing. I did it last time as well. I'm going to remind you that if you cannot see the camera cannot see you, so please make sure that you see the camera. The second thing is it's probably going to be on the moon, so you might as well smile. You know, it's a good it's a good practice.
So I'm going to do a fake selfie.
Okay, you're going to do a fake selfie, and we're going to do a. All right. On 3, say to the moon. Okay. 1, 2, to the moon.
To the moon.
Guys, you can do better than this. Do a little more crazy. 1, 2, to the moon.
To the moon.
All right, perfect. Thank you, guys. Have a great night.
Bravo.